the fuck? Just start streaming and then I get a message. Right. Not important. Hallo Nishkal and Sion Tuba. Let's go this. You're not interested in mathematics, or shall I just stop coding? So I'm modeling this as a matrix multiplication with some t vector, where t looks like this. So yeah, that's just a lame way to write down a polynomial. And then you can I don't know if you gain something really. But at least all the variables involved have a name now. The matrix elements. Okay, so saying that we have a point, the curve is going to be equal to that point when t equals 0. That would be P0. And if t equals 1, then it has to be P1. And then we have a direction vector that points in the direction that the curve is going at t equals 0. That would be D0, and the same thing for D1. If you worked it all out, we get that the point of the curve parameterized by t, so this is two-dimensional xy coordinate, is P0 plus t times some positive value times the direction in which it is going at P0, which is super logical, because if t is very, very small, then t to the power 3 and t to the power 2 can be ignored. These are then not relevant. So in first order, that's exactly the direction that we're going into. Yeah, if you increase t a little bit. Moreover, you see that if t equals 0, then this is 0, this is 0, this is 0, everything is 0. So if t equals 0, then we are just in point P0. If t equals 1, well, fill that in, then everything drops out and the only thing you're left with is P1. I did that yesterday. You can do it if you want. I'll be on you, hi. And last thing, of course, if you take the derivative of this and then look at the value of the derivative at t equals 1, then you'll exactly get beta times t1. So this is the right formula. Let's write a program that visualizes it. That's going to use this. So I had a slider, I think, for alpha, and a draggable point. You could drag around the circle for the direction vector, but might as well combine them, those two. I could make you can make a point, yeah. I think I'm even going to destroy this code, that is delete it without having committed it. No, I can't do that. Git status. Completely new file. allow printing direction, fix operator minus, and work on the readme. That's it. VIP. Swap operator minus points, right? Clean. Now I can destroy it. So I don't want to have sliders for alpha. I don't want to have sliders. I don't want to have sliders at all. No sliders. We have draggable points, P0 and P1. Now I want to add... I don't even need a circle really around them. I'm just going to add 2 more points. Yeah, there's no Q. Going to call it D0. So D0, the vector from P0 to D0 is then my direction vector. Not just the direction, but also the length. The length is then alpha. So alpha times D0 is actually, I'm calling it D0, but it's not a direction vector anymore. I plot it as a point, otherwise I can't drag it. Let's use a different color for the D's. What is the color of a point color? Point style. Oh, that works with color indexes. Yeah, the reason I did that is so you can make a lot of different colors without knowing which color it is, just that they are different. Incremental color. I don't know, let's try 2. It's called index. Everything is draggable. That's more like the circle itself. I'll do circles. Rotating of Q. Right. I think that's it, apart from everything else below this. Defining the matrix still, yeah, and then we have it, right? I just have 4 points now that all can be dragged. So we want that. Well, it's the means that the matrix is looking as follows, and this is these are two equations for x and for y, and it just means that for x the top row of the matrix applies and for y the bottom row of the matrix. So the top row would be p x0 plus, and now we have alpha d0, and that would be this one. And because it's the second column, it's times 2. And then the next column is times t squared, and the next time is times t to the power 3. So I really want to fill this in. Why not? So this is this vector, but then just x coordinates. And the same thing, but then the y coordinates. And then I'm going to abbreviate these things with velocity, I think. Just get rid of the alpha. Let's call this v. And the t to the power 3 thingy. Right. Well, then we need, of course, the v0 and the v1 vector. Which is literally, I mean, already to a connector, so why not use it? This is the D0 arrow and the D1 arrow. So that's a vector from P0 to D0, which is just D0 the point. I'm going to use that as the velocity vector. And then, no, this is row 0. The first column here is a row, and the second is the column. So M00, M01, M02, and so on. M00 would be that one. M10 is that one. M01 is this one. Oh, let me change that also to V. That is V0x and that's V0 dot Y, and this is then might as well do a helper variable. Vector I'll call it V3. 0, 1, 2. Let's call it 2. The 2 of t squared. So this V stands for velocity and this V stands for vector. Do not be confused. That would be then 3 times E1 minus P0 minus 2 times V0 minus V1. And the vector V3 is then this one, minus 2 times the same thing, plus V0 plus V1. And then here we can just fill in M03. What the hell would I do that first? What is the thing at the end? Okay, so we have 0, 0, 0, 1. Now I want to do 0, 2. And then of course 1, 2. And so on. And this one is V2x. Maybe I should do something else on V2, but well. V2y. V3x. And V3y. The matrix has been defined. Of course, it compiles at once, first time, especially because called add plot front of everything. As explained yesterday, it's just a convention that I call them plot underscore something when they are in a namespace plot point, and they must be, otherwise you can't drag them. The shift key didn't work. It's not my error, just fault with the shift key. And then we are going to run it. Dread ik my cubic, man. And of course it works at once, does it? I have the feeling that it's, yeah, maybe, I don't know. No, totally not working, does it? Yeah, actually it is working, isn't it? I think it's working. At least D0 is connected to P0, D1 is connected to P1. And if we drag this thing, yeah, sure, that's the speed and the direction. And where it goes, but it's a bit choppy. Let's make small steps. Still very rudimentary curve at the moment, which is just straight lines from point to point. Maybe too short, let's see. That one is long enough. It stops at P1, interesting. Oh yeah, interesting. I'm an idiot. It's not interesting at all. So now we go from -1 to 1. Let's go to 2. Because 1 is P1. Okay, now. So yeah, let's say you have something like this and it, oh, come on, drag. That's going in that direction and this one is going in that direction. Well, very loopy, man. Ridiculously looping. Whoa. I would say, hey, fit that with a parabola, but no. It wants to do this. That's pretty madness. Hey, Devin. I'm kind of shocked, man. Why the hell is this always an S? Huh? Wow. That's pretty crazy. I just have to make them much larger. And here also. You make the speed large enough that it becomes a parabola. You can never drag that point again. It's outside the window. Oops. I'm gonna put them a little bit closer together. Let's say my mouse is so broken. Pretty close. It should still be possible to make a pearl, of course. Why is this not looking like a pearl? Okay, now we are talking. Yeah, something like that. So let's make them on the start of this position. This is the point where normally I would start to write a button, so I can click on it, and then it saves this to disk, so that if I run it again, it starts in the same position. But then we are 5 days further. Well, 2 days, I think. Yeah. Or you can just take a pencil and write it down. So that is minus 2,0. That one is at 2,0. And D0 is at, well, 1.5. 2.5, 1.5. And D1 is then, I guess, the opposite. So plus, I'm going to add plus 1. So that's 3.5, comma, and then negate it, minus 1.5. Let's see what that does. And I was going to make this one longer. 2 and 4, because it was shorter than the other one. And then we have starting points. Minus 2 and 0 and 0 and plus 2. And this one was 2.5. So both positive, yeah, I guess. 2.5, 1.5. And this is, I did 3.5 minus 1.5. Almost. I think this should have been like there, at the very least. Yeah, it's pretty clear, I think, that What happens beyond P0 and P1 is absolutely horror. You should never use that. Damn it. Now you can derive the tangent, slope, whatever, you know, maybe from the next data point. But then we still have this speed thing. See, if I make it too large, then strange things happen here as well. So what is a good one? Also, the whole thing is pretty asymmetrical, because D1 is pointing away from P0 and P1, and this one is pointing towards it. So they are not really treated in the same way, it seems. It's going through the D1 point. Yeah. Cha. So while fitting data points, and we have fitted this one, D1 gives the direction at least, right? So the next data point, the next fit, then the D1 is the D0 of the next one. In other words, D0 comes from the previous fit, so we already know D0. That's kind of fixed. We know D0, but we don't need it. We don't really necessarily know the speed. Okay, the length of this vector. I mean, for the next one, you know the direction, but could be that, say, the previous data point was very close to P0. And the speed is just not related to this one. I think the speed is kind of related to it maybe, but then in terms of chord length ratio, if the previous point is way closer to P0 than P1, then yeah, you need to start scaling at the very least. And I think that's what people do usually. Or you could do too. So you kind of approach the problem then as a linear one in this respect. You say, well, I have a data point here, say, and this distance is short. I don't care how the curve goes. I'm just saying, well, from there to there, that's short. And from there to there is longer. Therefore, it's closer to this point. That should kind of hold, because you don't want to fit this with curves that go like way away and then come back here, and then actually the chord length of the curve is much longer than the distance between those 2 points. Although it could happen, of course. If you want to make it really slow, I mean complex, then I guess you could look at the chord length, take that into account. Then we definitely get a numerical way to fit this thing. I don't want to go that way. Plus I have my doubt if that's correct. I think the speed at which even a given Bezier curve, so this is a single curve, I think the speed here is way faster than here. I think that it's probably the more it is curved, the slower it goes. And then it goes faster again. So here's its most curved, so it goes slow here. And then faster here. So yeah. How can you talk about a length then? However, and that was my plan before I even started streaming, we can assume that, I was doing that anyway before, that the perfect curve is a quadratic curve. And then from that, I think I can calculate at least the direction. Still not the speed, but the direction. I think that's the first step. And then we have at least 2 directions. I would still not have the length. But okay, do that afterwards then. Yeah, so I'm going to add another data point. That would be P gamma after P1. And then I want to fit a parabola through, actually I want to fit a quadratic Bezier through those 3 points such that it is tangent to D0. And with the experience of the last month, or how long I've been doing this, I should be able to do that, right? I think I got the quadratic Beziers pretty much nailed down. Or did I? So So the quadratic Bezier. I want to draw a quadratic Bezier, which goes through 3 points, not 4, like in this case. So I want to drop P beta actually. And instead of P beta, define this green arrow. Yep, we don't have P beta, but we do have the direction, the tangent in P0. And then I want to get this rotated parabola from the fact that we know P gamma. Although this is also using the fact that mathematically it's easier, but the problem isn't really different if you just put P0 and P1 on 0, 0 and 1, 0. So it's rotated and scaled. Maybe you should look at it again from this perspective of trying to fit a quadratic curve. And not use all this S and W and alpha stuff. Right, let's just do that. I'm sitting in the dark. I'm going to turn on the lights. Be right back. Nothing to eat. Okay. So I want to revisit NS2, quadratic Bezier, but then do it like I'm doing it here. No special case for P0 and P1, just arbitrary coordinates. Now let's just begin with a little bit. Guess I have to continue with it though. The velocity vector v0. So this one is gone. Just move everything well down. What's t squared? So this is the derivative of t, and then this is the derivative of t squared. So v0 is no, I get the same here. X shift T P or something. Where T is 0, so this is a 1. Now you get obviously the same elements of M. And then we have yeah, I want to work indeed with just a direction, so let's define that again. And then with that, we can rewrite M. I think I can already fill this one in as well. M02 is equal to px1 minus these two, and I have those there. So I can just fill this in. Actually, I deleted the wrong column, I guess. The last column was more like it. So this is p1x minus p0x minus that, and then again for the y coordinate. Well, it looks about right. Because this still holds. Surely I have a use for this. The 3 is gone. And the 2 is gone. And the beta is gone. And the rest is gone. So. And now we can fit alpha to the next data point. Where is the... I lost... Oh, yeah. Thought I had a better one. The search in this one is really bad. This one. Oh wait, I need subscript comma. Subscript comma. Except that, of course, we don't know the t then. I'm gonna solve... Ugh. Well, t is gamma, but we don't know gamma. So now I need comma after all. Nope, not that comma. Subscript, comma. Or maybe it will, yeah, well, I guess I can solve both because we have really two equations, x and y. Surely I have B0 as a vector. Yeah. Now let's just write the two equations immediately. Alpha times dx0, and here we have alpha times dy0. Okay, I'll use dot. Plus, times gamma. By the way, chats, I have cancelled my subscription on ChatGTP. It is not helpful. It's just too stupid. So really, no. Ugh. I'm getting the same feeling about ChatGTP 4 now as I had about ChatGTP 3. It's a pure waste of time. And that happened while trying to do some mathematical derivations where it couldn't do anything right. And even if I guided it, like multiply both sides by, subtract this equation from that equation, it didn't number the equations, it got confused. It was one big horror. And then eventually I got a formula. So the whole, after lots of corrections, it got some end result, and then that end result turned out to be wrong. Well, I tried it out in my program and it didn't work. So then I say to ChatGPT, well, it doesn't work, so there must be an error. And then it comes with a shitty list of possibilities, including C++ round-off errors and complete nonsense. They say, no, in the derivation that we just had in this chat is a mistake. Find it. Nah, no way. So it's just completely useless. It's absolutely 100% useless. It's not an AI even close. I really see it mostly as an ELIZA program with a neural network behind it. Yeah, it's a large language model. That's what it is. It can't reason. It doesn't know mathematics. They can't tell a plus sign from a minus sign. So no more ChatGPT. That is, I still have it until the end of this month or so, or the end of next month even. I cancelled it on 26 January, and then they say, sorry to see you go, but well, you still have access till 28th of February because you paid until there. What? How about paying me back? Assholes. Doesn't even feel legal. But okay. So I might still use it a little bit because I paid for it. We have to do this. Oops. X. Insert Y. Yep. Now solve alpha and gamma from two equations. That should be possible. How shall we do that? I guess first thing I should do is get rid of the gamma squared. That will give me an alpha squared. Is there a smarter way? Getting rid of alpha is not as easy. Neither is easy. I think I'm gonna get rid of alpha first. Yeah, from this follows that alpha is maybe not that fast. So let's do you get the x out of there. It is alpha dx0 times gamma minus alpha times dx0 gamma squared. Plus that times gamma squared. Ain't that correct? I'll do it again. Double check. Alpha times that times comma. And then this is, yeah, it's just what it is, right? Just minus that. Alpha, yeah, times comma squared. Plus that times comma squared. All this drops out, subtract that, right? So multiply this with dy0. This one times dx0, therefore they become equal, subtract, gone. And here we have this times dy0. Subtract this times dx0. No, then it's even easy. It's just gamma squared. So you can solve gamma squared and then you have gamma after taking the square root. See here, dy0. Can we combine this? It's also a minus. I want to rewrite this. From that follows that Let's group everything by X0 first. And let's bring everything to this side as well. So then I have minus that. X0 plus that. Yeah. Can't combine gamma 0 with that. So it is this minus that times dx0 plus something times dy0, of course, which then is equal to that, I guess. And we have to subtract this one to minus that. Let's make this a negative. Sure, doesn't look right. Good, like that. Plus this times dx0 minus this times dy0 all the times gamma squared. Got to the equals 0. Yep, so gamma squared is this, which is actually a dot product between the normal of the vector from P0 to P gamma. Yeah, how to write that? Maybe I should not write it here yet. You can do that in the code. No, with the minus in front of it again. So it's more like the vector from gamma to P0 then. Can work with that. Now, and then alpha is I'm afraid I have to. Would be nice if I did not have to calculate its square root. But yeah, there's no way. Alpha is just here, so we need to divide by this. We need to know the gamma. Let's calculate instead alpha times dx, because the x0 might be 0. It's the same value as that. That is this minus that. Minus that, I guess. Divided by comma times a comma squared. So apparently gamma cannot be 0. And it would be 0 if these two are equal, which means that the direction that d0 is perpendicular to the normal of the vector from p0 to p comma. Interesting. Can I picture that? Yeah. It's basically what it says is that there is no solution if the vector from p0 to p gamma is perpendicular to the tangents here. Let's try that. Oh, really? I think I pretty much have it already. To build this line, now we have to be perpendicular to that one. Totally, I can just rotate it past that point. That's strange. Yeah, I get it. Okay, let's hope that it is just logical. Likewise, this cannot be 0, I suppose. Which is the dot product between the normal of a vector p0 to p1 with the direction vector. Oops. Well, that's also not true. Man, what the hell? Yeah, so vector p0 to p1, it's horizontal obviously here. And then the tangents in p0 is the green arrow here, which is totally perpendicular to it. Oh wait, perpendicular to the normal of that. Ah, right, so I have to, that means parallel with, yeah. Yeah, and then it makes sense. Okay, so it says that it's not possible to make this green thing go parallel to P0, P1, which is correct. I can't do that. I mean, if you do that, then things explode. So it doesn't even draw it anymore. For obvious reasons, because that would be a parabola that is a straight line here, and then it can return over the same line, but you'll never hit P comma. Suppose I made the same mistake with the previous thing. So that was, yeah, that's, I did it perpendicular, but you have to point it in this direction. So this cannot point in the direction of P comma, and it's just the same problem. Then you're at this limit, I think. Infinitely stretched. No, it was this one, huh? From P0 to P comma. Probably the same thing then here. Yeah, so parallel. Like literally disappears exactly at that point. So it is correct. See, there's disappearing means that there's somewhere is not a number, so it doesn't exist. If we move p beta a little bit up, then it exists again, even though dubious. But you see that the tangents in p0 is no longer pointing at p comma. You would say yes, it is, but it's just past it. So I move it higher, then it rotates below it. So as soon as it points in exactly at p gamma, it's gone. And then if we move it down, it comes back, well, I don't know, there. Totally not pointing to p gamma. Sorry, I have to go look at this one, not at that one. What's that? What was that? Yeah, that in this case, that is the case. So that makes sense then. Good. No errors here. Alpha dx0, that came from here, equals px gamma minus px0 minus px1 minus px0 gamma squared, everything to that side, divided by gamma minus gamma squared. Looks good. And then we have gamma times, you know, this one equals now everything is symmetrical anyway. But I am going to do it again just to make 100% sure, well, 99.999% sure that I did not make a mistake. So this thing is equal to that minus this one minus, and I put parentheses around it to show that it is equal to what we calculated before. This one minus this expression, yeah. And then we add some fancy spaces to look cool. That's it. And then we realize that D0 is a direction vector, so I can square both atom, and then we get alpha squared. Alpha had to be positive, so why not? Yeah, how do you square that shit? Is anything going to drop out? I don't think so. Just an X and Y combination. Oh, that's a huge formula. Divided by that squared. And here I have I'm going to write this different. Why not? Let's remove gamma from it first. Also have to square that times 1 minus comma squared. Comma squared times 1 minus comma squared. And this is all of that squared plus all of that squared. No, I don't believe it. 2 hours ago. Oh wow, on Mac. I don't know, Mac. Plus people already answered it because it's 2 hours ago, not now. Yeah, the big question is, of course, can we have a negative gamma? That would definitely change the solution for alpha. So it seems that there are two solutions then. Gamma, gamma, gamma. What was gamma? Gamma is that. Oh, right. No, gamma is positive. Yeah, gamma is larger than 1 even, so it's never going to be 0 anyways. Could become plus infinity in certain cases. So yeah, larger than 1, so it must be definitely plus the square root of that. And this one must be larger than 0, so that's also just plus the square root of that. And now let's write a program for it, so we can see if this is correct with the visual feedback. So instead of what? Instead of having D1 and a cubic Bezier, I want now to have another point here called P gamma, and then we can leave this, I guess, but then I want to draw a cubic Bezier, not a cubic Bezier, a quadratic Bezier through P gamma, which you can drag around, such that it goes through P gamma, through P1, through P0, and the tangent is equal to D0. Which then will reveal what the D1 is. At least the direction. That's the idea. Therefore, I need one new point, just P gamma. And then define a quadratic matrix, quadratic Bezier matrix. There's our new point. Let's put it a bit further. Maybe here, 7 minus 2. Right, a draggable thingy. Then we have the problem that we must calculate this. So that seems to be based on a vector from P0 to P comma. Next. Let's first draw this curve. So the intention is to determine a quadratic Bezier going through P0 and P1. So copy it from here. P1. So do I have a P comma? Did I really delete everything? I just deleted it. No, here it is. Still need my P1. Yeah, I'm definitely going to need D0, of course. Do I already have that then? I have a V0, right? Yeah, I call it V0. Is that a direction? It's not a direction. So D0 is the direction of this vector, yeah. I don't want to have the amplitude of it. So let's start with D0 then. It's like literally a direction vector, let's call it that. Direction D0 is the direction of V0. And then I have a vector from 0 to gamma. P0 to P gamma. Probably need even more. From 0 to gamma, this is from 0 to 1. 0 to gamma, 0 to 1. 0 to 1, 0 to gamma, 0 to gamma, everything is from 0. Either to 1 or to gamma. So P0 to P1, turn them around. Plot. And then I need a vector such that the dot product with D0 is this thing here. So that will have the coordinates of I think this is from, right? From 0 to 1. That has the right coordinates, but then it's the y coordinate. So xy is swapped, and then the y coordinate is negated, which means an anti-clockwise rotation by 90 degrees, which is my normal vector. That's the way I define the normal vector. So it's a normal vector of the thing, dot product with D0. I'll go straight for gamma, I think. Gamma squared. Call it again, really. I think the second one. 0 to gamma. And then the normal of that, because the normal is... And normal is a negative before that one. Oh, that's not what I wanted then. So I want this one, swap xy, and then the... Yeah, just the normal inverse then. I want to negate that one. Yeah, that's what I want. Don't like to use that though. So maybe I should inverse my... I can just inverse the vector to begin with, and then use a normal. Why? Who cares? Yeah, I do. Okay, so the x would... Oh, what the hell, man? Why would the x would counterclockwise? Yeah, this is correct. This is correct. So swap them and then change that. Okay, let's rename it from P1 to P0. So that's also kind of a weird definition, I must say. Yeah, if I want to see this as a normal, I have to negate this and plus that, which then of course means that we have to talk about that minus that instead to keep it the same. Means that the 0 comes up front, so I want to do that here as well. And then here also just keep put the P0 up front everywhere. Yeah, since gamma is larger than 1, and this is now gamma times 1 minus gamma, I think it should negate this one. And then again negate the above. Or just write gamma times gamma minus 1 immediately. Same thing here. Yeah, or whatever. So I was working on this one. I need something that has the x coordinate of plus 0 minus gamma. And I'm passing 2 points. The x coordinate becomes something minus something, or this is x, sorry, this is 0 and this is gamma, so from must be gamma. That's the first one. So I must construct it from gamma, comma, and that's then from. So it is from gamma, okay. From gamma to P0. So this must be reversed. this one too. No, that is P1, P0. From P1 to P0 and from P gamma to P0. And now I can use P gamma P0 normal. And then the dot product with D0. Divided by so now we go from 1 to 0 with also with D0 dot product. Alpha squared is this. I guess that is related to the length of these vectors. The square of the length of these vectors. If I write this out, do you get something sensible? For example, if you do the squares, then you get the square of this here, and you get the square of that there, and you add that, so that would be the square of the length of the vector from 0 to gamma. Likewise, we get the length of this one times gamma to the power 4. And that is, yeah, plus the square of this whole thing. 0 to 1, and then again. And then we have this times that times 2. And that's something entirely different. That's probably a dot product again. Let's write it out. Write it out. It's so this square here, this thing is actually equal to this squared minus 2 times this times this plus this squared times gamma to the power 4. Are my subscripts again. Superscripts, I mean. Superscripts for this is correct. So the thing squared plus 2 plus that squared. Yep, totally looks okay. Plus, and then we got this one. So this squared minus 2 times that plus that gamma to the power 4. Oh wait, this must be squared as well. Which equals the length of P gamma I'm negating it because we are in the code working with this. 2 squared, oops. So that's this plus that. And then here we have another square. Well, that would be the square of the length of P1 minus P0. Times gamma to the power 4. So that is this plus that one. And then we are left over these things, which is gamma squared, both of them minus, so do just minus 2 times something gamma squared. Or the something is this plus this. which is again a dot product. Not really sure how useful it is to write it like this, but yeah. Well, I guess I need a vector p1 minus p0 multiplied by gamma squared. Then all the gammas drop out, or they'll just become part of that. The square of a vector, kind of like feels like it. Well, nah, I don't know. So, so we already have these, right? So gamma minus p0, that's a vector. Right, next. So this vector was created from 2 points, as in this one, and it is the second one minus the first one. Could be kidding me, right? This is not. I said I was negating it because I thought that's what we had. But no, this is what we have. Or is it not? What? No, yeah. I was working with vector from gamma to 0, so that's this. Just subtract it from 1. And it must be times the comma. Let's make a new one first. So that's the one vector. I can just multiply it maybe. Multiply this one with the comma squared. And then it works. Minus 2 times this, which is then again a dot product of what? There's no normal involved here, just x, x, y, y. That's just a dot product between those two. And I refuse to use ChatGPT. So Google it the old way. Square of length of vector. The name definition formula. Magnitude. You learned the length of red will know the magnitude. I was thinking that the square is the norm, though it depends a bit on what field you're in. And since we're not getting anywhere, maybe I should just type the word norm. Nope, can't find it, damn it. Okay. No, that's not what I was looking for this. Yeah, STD norm returns the square of the distance norm. As is the case with the field norm of the Galois extension of complex numbers of the real numbers. Hence, STD Z norm is not the distance. So norm is sometimes used for the square. Yeah, if there's a standard norm that is a square, I don't know. Okay, that's a norm of complex numbers, so it's slightly different for a vector maybe. just add it the way I named it then. Length squared. Let me see if this compiles. It does not compile. No, it's a constructor for initialization of director. Yeah. Guess I made it explicit. Undeclared identifier plot comma. Plot p comma. No member name normal in cairo and vector. I only have a normal in a direction apparently. What? It's kind of weird, of course. Yeah, I have a direction normal. My vector is called, and this would be the normal. Theta 90 degrees. Horrible. What a name. I cannot multiply like that. What the hell? Whatever I want to. This exists. I'm just going to add it. Yeah, it's called length, yeah. Nobody knows why it is called length. Refuse to call it length. Right. It compiles. Well, but we're not drawing anything yet. That's wrong. Plus I forgot to divide by. Divide by gamma squared, wasn't it? Times 1 minus gamma squared. No. Divide by this. Yeah, it's all squared then. Gamma squared times gamma minus 1 squared. I have this feeling that I made a mistake somewhere and it's just not going to work. And then we have to do everything again just to find the problem. Go over everything. It's a feeling of doom. I think I'm going to eat before I run into that problem. Again, I forgot it. Divide by gamma squared, okay. Times 1 minus gamma squared. If you wish to do this differently, then just call del square. Yep, to draw the damn thing. Can't do that. I'll first have to make a matrix. because this is the matrix. Got those two. What can go wrong? Well, that. Make. Shall I go eat first or shall we just run it? Yeah, you want me to run it, I know it. I'll just run it and crash. No, no crash. There's a parabola. It's going through P gamma, it's going through 3P1, it's going through P0, and it has a tangent equal to D0. No errors. So there. Ha 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 ha. God.